There, welcome to CXC Math TV. Today we will be looking at the Integrated Mathematics June 2016. Nice. So we know it has 3 modules and you need to do every question. Alright, 3 modules, every question, 2.5 hours. So question 1, module 1, Foundation of Mathematics. It says find the complex solution of the equation x squared minus 2x plus 5 equal to 0, giving your answer in the form x plus or minus I times y. So the first thing we notice is that they told us it have what? A complex solution. Since it have complex solution, we already know what to do. We know we have to use the quadratic formula. So the quadratic formula, remember, is x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. That's the quadratic formula. In this case, our a would be the coefficient of x squared, which is 1, or b would be negative 2, and our c would be 5. And I know the yellow might be annoying, so let me change from the yellow. So in this case, we're going to say x, or solution. So our solution now of the quadratic equation, x is equal to negative 2, which is positive 2, plus or minus the square root of b squared, negative 2 squared, minus 4 times a times c divided by 2 times a. In that case, we need to evaluate this square root part of it. So this square root part of it is negative 2 squared is 4. So that is 4. Then minus times 1 times 5, that's 20. So this is 4 minus 20. So it's the square root of 4 minus 20 over 2. Then we have to remember, in this case now, we're saying then 4 minus 20 is negative 16. So x is now 2 plus or minus the square root of negative 16 over 2. But remember, the square root of negative 16 is the square root of 16 times the square root of negative 1. And the square root of negative 1 is I, and the square root of 16 is 4. So this is 4i. So we get it is now 2 plus or minus 4i over 2. Then we need to divide each term by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. So the answer is 1 plus or minus 2i. Now we're not going to write 2i because they say write it in the form x plus or minus iy. So I'm going to write I times 2. Alright? So if you had left the answer like this, nothing is wrong, 1 plus or minus 2i, that's your answer. But because it says to write it in the form x plus or minus iy, I want to just keep it in that form. Alright, I want to keep it in the form that they told us. Now look what I'm going to do. This is your answer, but I would recommend everyone to get a Casio 991, 570 or 115. To do these type of questions, you can actually solve the equation in your calculator. So we're going to go to mode, then we're going to go to equation, and this is a quadratic, so we'll press 3. Then we'll insert the coefficient. Coefficient of x squared is 1. Enter. The coefficient of b is negative 2. Then we enter. And the coefficient of c is 5. And then we enter. Then we press equal. It's going to solve the equation for us, and look what it's going to give us. Our answer is the first root is 1 plus 2i, and the next root is 1 minus 2i. Wow! Just like what we have right here. If you have one of these calculators, you are golden. Alright, so that's why I recommend one of these Casio calculators. Alright, So now that we got that out of the way, part B. Part B says to solve the pair of equations simultaneously. So as you can see, it's a nonlinear equation and a linear equation. Remember, anytime you say x squared, that's the nonlinear. And then the other one, once it takes the form y equal mx plus c, that's the linear equation. So you always substitute the linear into the nonlinear. So what I'm going to do is from the nonlinear make y the subject. So let's call it equation 2. So from equation 2, making y the subject, we'll get y equal to 2x minus 4. We just bring the 4 over to the right side of the equation. And so we can sub y equal 2x minus 4 into, let's call the first one equation 1. So we're going to sub it into equation 1. Substituting that equation in equation 1, we're going to get 3 in bracket, 2x minus 4 is equal to x squared minus x. So expand inside the bracket on the left side. 3 times 2x is 6x minus 3 times negative 4, that's minus 12. That's equal to x squared minus x. So what we can do now is bring everything to one side because we realize we're getting a quadratic equation. So I will bring everything to the right side. So have this as 0 over here. Bring 6x over here. We get x squared minus 6x from x is minus 7x. Then bring the minus 12 over here. This is now plus 12. So all we need to do now is factorize this equation. So we draw up our brackets. And this is saying signs are the same and both factors have a negative sign in them. So we put a minus and a minus. Now I know many of us are not accustomed to this, so we're learning a new way. The plus right here means both factors have the same sign and both of the sign is minus. Alright? And so now we put a x and a x because the only way we can get x squared is if we multiply x and x. Then to get 12, it must be 4 times 3. That is it. So in this case, we get x equal 3 or x is equal to 4. Really, really, really nice. Now, once you get x equal 3 and x equal 4, you're not finished. You need to find your y values. So we're going to substitute into this equation up here. So notice when we put in 3 in the first equation, 2 times 3 is 6. 6 minus 4 is 2. And then when you put in 4, 2 times 4 is 8. 8 minus 4 is 4. So those are our answers. So the pairs is 3, 2, and 4, 4. That's our answer. Nice. Now, one thing I recommend is to always check your answer. Check your answer in both equations. Alright, so to check your answer, what you need to do is check if it makes sense in both equations. So 3 times the y value of 2, that is 6. And we need to ensure that it's equal to, when you put in its x value, 3 squared minus 3. Is that also 6? Yes. You can check it with the next equation, 4. 3 times 4 is 12. 4 squared is 16. 16 minus 4 is also 12. So we can see that the first equation is good. And naturally the second equation would be good because we resubstitute it into the linear equation. So we know that we're correct now. These are our answers. Alright, moving along the way, this question here, it says, find the equation of the straight line that passes through the point 0, 2 and is parallel to the line AB with coordinates 5, minus 4 and minus 3, 2. Now the first thing we need to remember is, I just want to put as a side note at the top, if two lines L1 and L2 are parallel, then you need to remember that the gradient of the two lines will be equal. When M1 equal M2, both of them will have same gradient. So in that case, we just need to find the gradient of AB first. The gradient of AB, remember, it's y2 minus y1 over x2 minus x1. So 2 minus minus 4 is positive 6. Minus 3 minus 5 is negative 8. So that's minus 3 over 4. So we're saying that the equation of L, this line also has gradient equal to negative 3 over 4, since they are parallel lines. So in that case now, we can say, alright, now L passes through which point? L passes through 0, 2. So L passes through 0, 2. And so if L passes through 0, 2, that means the equation of L, so therefore L is given by, this is the equation now, y is equal to negative 3 over 4x plus 2. That's your equation for L. That's the answer. Nice. Alright. Now, part D. Part D, it says, obtain the binomial expansion of 2x minus 1 all cubed. Now, there's a binomial expansion formula which I'm going to write down, and I want us all to know it. You don't have to always use combinations. I want us to know this formula. The formula for a plus b all cubed, it's equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. That's the binomial expansion formula for a plus b all cubed. So what I'm saying then is, looking at this question, you have 2x minus 1 all cubed. So I want you to remember this, remember this formula. So 2x minus 1 all cubed. Really and truly what we're saying is that our a is 2x and our b is negative 1. So the formula would be 2x all cubed plus 3 in bracket 2x squared times minus 1 plus 3 in bracket 2x times minus 1 squared plus minus 1 cube. That's what we're saying. 2x cube is 8x cube. 2 square is 4. 4 3 is 12. 12 times minus 1 is minus 12, so that's minus 12x squared. Minus 1 square is 1. 3 times 2 is 6, so then that's plus 6x. Then minus 1 cube is negative 1. Notice how easy that is, just knowing the binomial expansion formula. Wow! 8x cubed minus 12x squared plus 6x minus 1. And that's it. Easy. So this answer, just to write it back again right here, it's 2x minus 1 all cubed. We said it's 2x cubed plus 3 in bracket 2x squared times negative 1 plus 3 in bracket 2x times minus 1 squared plus minus 1 cube. And then after we do that, we can say, okay, this was 8x cubed minus 12x squared plus 6x minus 1. That's our answer. Alright, now part C says, determine the range of values of x for which the quadratic expression is greater than 0. I love when you picture what is happening on a quadratic graph. On a quadratic graph, right, the portion of the graph when it's greater than 0 is always above the part of the graph that's above the line y equals 0. So these parts of the graph. So the first thing we need to do is identify when is the graph going to be equal to 0. We need to identify the roots. So if we factorize it, what we're then saying is factorizing it in one bracket This is saying signs are different and the bigger number get a positive. So it is 2x and x. And we know it has to be 3 and 1. And it's saying signs are different, the bigger number get the positive. So plus here and minus here. Wow. I am telling you, knowing this quick way of factorizing save you a lot of time. So in that case now, if you look at it, check it back. This times this give you that. 2x times 3, that's 6x. Minus 1 times x, that's minus x. Minus 1 times 3, minus 3. This way saves you a lot of time. So the roots therefore would be negative 3 and positive a half. How do we get the roots? You'd set each factor being equal to 0. We don't have time to do that. This is elementary. Setting it equal to 0, you get the half. And from the other one, you get the x plus 3 equal to 0. So x equal negative 3. Alright, so those are our roots. So since those are our roots, right, and we have our graph right here, now we can write down the solution. So the range of values of x is going to be x is such that x has to be less than negative 3, or, so we can put a union symbol for or x is greater than a half. This is our solution set. Alright, x is either less than negative 3 or x is greater than a half. Now look at it. I love to verify solutions for you. So give me a number like negative 5. Look at this. We're saying 2 times negative 5 squared plus 5 times negative 5 minus 3. We're saying that will be greater than 0. Look, it's going to be a positive number. Greater than 0. Because looking at the quadratic graph, we're saying on this case right here, so when you have a number like negative 5 right here, the corresponding y value is 22. Alright, that's all we're saying, guys. That is all. And so that would be the range of values of x for which this quadratic inequality or this quadratic expression is greater than 0. Alright, part F. Part F says a function f of x is equal to x cubed plus x squared minus 4x minus 4, where f of minus 1 equal to 0. And it says to factorize f of x completely. So if we are going to factorize f of x completely, what did they just give us? They gave us f of minus 1 equal to 0. So what they literally just gave you is they literally gave you that x equal negative 1 is a root. Now depending on your preference, you can either decide to use polynomial division or you can use synthetic division. In the interest of time, I will use synthetic division, but I'm also going to do polynomial division, no problem. Alright, so this is using synthetic division. Using synthetic division, the root is minus 1. Then you write down the coefficients of f of x. It is x cubed, coefficient would be 1. Coefficient of x squared 1. Coefficient of x negative 4. Coefficient of the constant negative 4. Then what do we know? Using synthetic division, you bring down the 1. Then you multiply. Minus 1 times 1. Minus 1 times 1 is negative 1. Then you add them. 1 plus minus 1, 0. Then you multiply again. Negative 1 times 0, 0. Then you add again. Minus 4. Negative 1 times 4 is positive 4. Negative 4 plus 4, 0. What is this saying to us? This is then telling us that f of x is equal to, remember the first root we have was x equal to minus 1. So x equal to minus 1 is really a factor x plus 1. And then now down here it's giving us the coefficient of our quadratic expression when you factorize f of x. So this right here is the coefficient of the x squared term. So we're getting x squared, then we have no x right here, then this is our constant, so it's minus 4. X plus 1 times x squared minus 4. Now look how quick this is going to finish now. So it's x plus 1 times x minus 2 times x plus 2. Because this is what? The difference of 2 squared. Since this is the difference of 2 squared, we're finished. Imagine that. Using synthetic division, we are done. How many marks for that? 5 marks using synthetic, and we're done already. Wow! That's amazing. Alright, that is amazing. Finish. We'll factorize f of x completely because these are the factors. Now, let's say you wanted to use polynomial division. I will also use polynomial division because I know some persons might want to use polynomial, or we only know polynomial, so there's no problem with that. So using polynomial division, it was given that f of x was equal to x cubed plus, was it plus? Let me look back. Plus x squared minus 4x minus 4. So if this is f of x and they gave us that x plus 1 is a factor. So since they gave us x plus 1 is a factor, then we just need to do our polynomial division now. So doing the polynomial division, we have x cubed plus x squared minus 4x minus 4. This is being divided by x plus 1. So now we're going to say x into x cubed is x squared. X times x squared is x cubed. X squared times 1 is x squared. Then we subtract. X cubed minus x cubed cancel. X squared minus x squared cancel. So this becomes 0x squared. Then we bring down our minus 4x. X into minus 4x, that goes minus 4. And then x times minus, then x times minus 4 is minus 4x. And then we say x times minus 4 is minus 4x, and minus 4 times 1 is minus 4. So we can bring down this minus 4 as well because we know we're going to subtract. Then when we subtract, minus 4x minus minus 4x cancel. Minus 4 minus minus 4 becomes 0. So in that case now we're saying that f of x, when we factorize it, we're getting it's equal to x plus 1 times x squared minus 4. Which still works out to be the same as when we did our synthetic division, x plus 1, x minus 2, x plus 2. Alright, so you could choose which way you want to do it in an exam. You can choose either synthetic or you can choose to do polynomial division. It's all up to you. Wow! Nice. Alright, that takes care of question 1. And so now we're at question 2. Hey! Question 2 says, given that f of x equal 2 ln x squared minus ln x, it says show that f of x is equal to ln x cubed. No problem. So f of x is 2 ln x squared minus ln x. By rules of logarithm, we know we can do what? We can bring up the power. We can bring up the power to rewrite this then as ln x squared being squared minus ln x. Now ln x squared squared is ln x to the 4 minus ln x. In that case now, we know that we can write log a minus log b as the log of a over b. That's a given. So let's do that. We can write this then as ln x to the 4 over x, which is ln x cubed. And that is it. Ln x cubed is our answer. 3 marks for doing nothing. Easy. Nice. Alright, part 2, it says hence solve the equation 2 ln x squared plus 2. It says hence solve the equation 2 ln x squared equal to 2 plus ln x, giving the answer to 2 decimal place. Hence meaning using what we did above. Using what we did above, we can say, okay, if we bring the ln x to this side, the equation becomes 2 ln x squared minus ln x equal to 2. But then we just said that 2 ln x squared minus ln x, we said that was what? Ln x cube. So that means ln x cube is equal to 2. Nice. So now it's way easier to solve. So now when we're solving this equation, remember logarithm is what? Log is remember the definition of logarithm is that the log of a base of a number is equal to a power. In that case, we're saying the number x cubed is equal to the base, and remember ln has base e, so it's e squared. So to find x now, we can say x is now the cube root, x is the cube root of e squared. That's your answer. But you cannot leave it like this, because the question specifically told us to give our answer correct to 2 decimal place. So we're going to take out our calculator and we're going to cube root that now. So let us go ahead and cube root it. Alright, so take out our calculator and now we cube root it. So cube root e squared. That's what we get, 1.95. So x is equal to 1.95. That's our answer. Now, of course, when you do mathematics, always check your answer. Always check our answer. So look how we're going to check our answer. Alright? Now, when you work out the left side of the equation, it should give you the same value as the right side of the equation. So look how we're going to check our answer. Right? So we have 2 ln x squared, which is our answer square, right here. This is what the left side of the equation is working out to be, 8 over 3. Let's work out the right side of the equation on the calculator over here. 2 plus ln the cube root of e squared. And let's see if it's giving us the same thing. If it is, we know we are correct. Of course it is. Wow! Both calculators are giving us the same answer when we put x as the cube root of e squared. So in that case, we know that we solved it correctly. So while you're doing the exam, you don't have to check over your paper at the end of it. You can check each question as you finish it same time. So we check that question. We don't have to check over when we finish the test. Now this question here, it says solve the equation 2 sine theta plus pi over 3 minus 1 equal to 0, where your answer is between 0 and pi. So your answer is in the first 2 quadrants. So in this case now, the first thing we need to do is bring over the 1 to get 2 sine in bracket theta plus pi over 3 equal to 1. We can then divide through the entire equation by 2 to get the sine of theta plus pi over 3 is equal to a half. In that case, we can draw our circle. Always draw your circle to remember where is sine positive. Sine is positive in the first and the second quadrant. Sine is positive in the first and the second quadrant. Remember, all school teachers care. Right? So sine is positive all here and sine here, the first 2 quadrants. So to find the corresponding angle in the first quadrant, we take sine inverse of a half. So sine inverse of a half, we know that should be 30 degrees or pi over 6. But if you don't remember, no problem. That's why we have calculators. Alright? So since we have calculators, we don't stress about these things anymore. Having issues with that calculator, so I'll bring out the next one. So we don't stress about these things anymore. So we'll put our calculator in radians and we go sine inverse of a half, which we know is going to give us pi by 6, but it's just, if you don't remember, you can just use a calculator. Please don't pay attention to the calculator on the left, it's having some technical issues. So now what we're getting is that theta plus pi over 3, we're saying that one answer is pi by 6. Or what about the angle for the second quadrant? That's telling us then that theta plus pi by 3 is equal to pi minus pi by 6. Alright, so in that case now, we can bring over the pi by 3 to get theta equal pi by 6 minus pi by 3. But pi by 6 minus pi by 3, look at this. Pi by 6 minus pi by 3. Notice what's going to happen. That's negative pi by 6. Negative pi by 6, this is giving us for theta. But guess what? This is not valid. This is not valid. Why is it not valid? This is not valid because they told us that theta needs to be a minimum of 0 and a maximum of pi. This falls outside of our range. Negative pi by 6 is less than 0. So this part of the solution we deny. So we have to work with the next part of the solution then over here. So in this case, we're getting theta would be equal to pi minus pi by 6 is 5 pi by 6. Then we bring over the pi by 3. So it's 5 pi by 6 minus pi by 3. Then we'll put that into our calculator. So let's do that. 5 pi over 6 minus pi by 3. Put that in the calculator and we get pi by 2. So theta is just pi by 2. That's your answer. Nice. Now remember what I said earlier? You don't need to wait until you reach the end of the test before you check your answer. You can bring out a calculator and check it from now. Check it from now. Look how we check it from now. 2 sine, the angle is pi by 2. So pi over 2 plus the next angle was pi by 3. So in bracket pi over 3, close the bracket, minus 1, and this should be 0. Bam! 0. Wow. So no correct already. Once you get that 0, you know you're correct, because that was the equation you initially solved. You solve for theta, that would give us that this equation equal to 0. Please check over your answer as you finish the question. Don't wait till the end of the test to check over your answer. Check as you go along the way. So in that case, we're finished and we look at part 2. Part 2 says determine the minimum value of f of theta, and they give us this same function right here. Find the minimum value. Now the first thing we know is that the sine of anything, let's call theta plus pi by 3y. We know that the sine of y is always between negative 1 and 1. Alright, I'm just calling in this bracket y. Now, what do we know then? We know that if we multiply it by 2, then 2 sine y going to be between positive 2 and negative 2. Then if we subtract 1 from both sides, we're saying that 2 sine y minus 1 is between 2 minus 1 and minus 2 minus 1. Minus 2 minus 1 is minus 3. And 2 sine y minus 1 is f of theta. And then 2 minus 1 is 1. So we're saying that the minimum value f of theta can take is negative 3. And the maximum is 1. They only want the minimum value. So we'll tell them the minimum value of f of theta is equal to negative 3. That's our answer. because they didn't need anything else. So we just give them the minimum value and we move along. Alright, part C. Part C says a length of a string is cut into 10 pieces such that the shortest and the longest piece measure 0.2 and 1 meter respectively. So it's cut into 10 pieces. So that means that we can always write down what they're giving us so far. N is equal to 10. And they told us that the first piece was 0.2. The first piece, A, is 0.2. And they told us that the 10th piece, you can call that T10, is 1 meter. It says further, when the 10 pieces are arranged in order of length, there is a constant difference between the consecutive pieces. Find the value of D, giving your answer correct to 3 decimal place. So what they just gave us now is a arithmetic progression. They gave us an AP. Since it's an arithmetic progression, we know that, what do we know about an arithmetic progression? We know that the last term right here is 1 meter. Now this is where you have to remember this formula. Tn is equal to A plus n minus 1 times D. That's what you have to remember. Tn is equal to. That's the nth term. So in that case, what we're saying then is that our 10th term, the 10th term which they give us was 1 meter. So 1 is equal to A, which is 0.2 plus n minus 1. N minus 1 is what? 10 minus 1 is 9D. So we can write that down. We can say, since there is a common difference, we can tell them that the sequence is AP. It's an arithmetic progression. So that implies now that 1 is equal to 0.2 plus 9D. And in that case, now we bring over the 0.2. So 1 minus 0.2 is 0.8 equal 9D. Then we divide both sides by 9. Dividing both sides by 9, we end up let's bring out the calculator. 0.8 divided by 9. That's 4 over 45. I'm just going to write 4 over 45 for D. D equal, oh, but this is correct to 3 decimal place. So I'm going to have to give them the decimal equivalent. Guys, make sure you follow instructions. 0.089 because it wants 3 decimal place. So 0.089. Please follow instructions, please. Alright, so that is that. So look what we're saying. We're saying that the first length is 0.2. Then you add this to it to get the next length. So 0.2 plus this. That gives us the second length. Then you add another 0.089. That gives us the third length. Add another one to it. Give us the fourth length. And you keep on doing it. And I'm telling you the 10th length will be 1. Alright, so that's all. Easy stuff. Nothing to worry about. Wow! Alright, part D. Part D, it says, over the 3-day period when prices of computer remain fixed, a firm purchased from 3 manufacturers X, Y, and Z at a cost per computer of X, Y, and Z respectively. The cost of the computers for each of the days is summarized in the linear equation. So they bought 2 of brand X, brand Y, and brand Z for $1,200. Then they bought X plus 4Y plus Z for $1,900 and 3X plus 2Z for $1,600. Using Kramer's rule or otherwise, where the determinant of the coefficient matrix of the system is 5, find Z. So the coefficient matrix, let's just call that matrix A. The coefficient matrix would be 2 1 1 1 4 1 3 0 2. And they're telling us that the determinant of that coefficient matrix is 5. That's all the information they gave us. Now, in order to find z, we have to remember that z is going to be equal to the determinant of the matrix AZ over the determinant of our coefficient matrix A. Now, what is that matrix AZ? The matrix AZ is when you replace that column, the Z column. This is the Z column. Remember, this is the X column, Y column, Z column. If you replace the Z column with the answers, the 1200, 1900, and the 1600, what we're going to get then is that AZ, alright, they didn't even give us a lot of space to do the question here. So our AZ is just the matrix. This is our AZ now, 2, 1, 1200. And then we have our 1, 4, 1900. And then we have our 3, 0, 1600. We close up that bracket. So in this case now we can say that the determinant of AZ is now equal to, now it depends on which row you're going to use. I am going to use the first row. So using row 1. Using row 1, this becomes now 2 times the determinant of 4, 1900, 0, 1600, minus 1 times the determinant of, cross out the row and the column with 1 in it. So this row we cross out, we left back with 1, 1900, 3, 16. So write that down, 1, 1900, 3, and 1600. And then we cross out the row and the column with 1200 in it. So plus 1200 times the determinant of, that would be 1430. 1430. So let's do our computation now. So the determinant of AZ is going to be equal to, and we work it out. So this is now 2 in bracket, 4 times 1600 is 6400 minus 0. And then 1 times 1600 is 1600. So we have 1600 minus 3 times 1900 is 5700 plus 1200 in bracket. 1 times 0 is 0 and 3 times 4, that's 12. So we have minus 12 here. Then just put all of this in a calculator. There's no need for you to be simplifying it and say maybe 12,800 minus what have you. Just put everything in your calculator. That's why we buy one, you know. So 2 in bracket, 6400 minus 0, close that bracket, minus 1, open another bracket, 1600 minus 5700, close up this bracket, plus 1200 in bracket, 0 minus 12. This is what we do, and we get 2500. So the determinant of AZ is 2500. In that case, we can finish off the question right here. And so Z is now 2500 divided by the determinant of A, which is 5. So Z work out to be $500. Now once I find Z, you're good. Alright, so Z is $500. So the cost of computer Z, $500. Now we don't know if it's US or Eastern Caribbean dollars. So I can't say if the computer is cheap. But what we do know then is, let's check if our answer is correct. This is how we check it. If Z is 500, this would be 2 times 500 is 1000. And so X must be 200. Because 3 times 200 is 600, and 600 plus 1000 is 1600. So if X equal 200, we're saying that this should be now 400 plus 500. So Y must be 300. Now the only way it gonna be true is if when we check it in equation 2, it balance. So just checking if our answer is true. So checking in equation 2, everything must make sense. So let's check it out. We're saying that x, which is 200, plus 4 times y, and y is 300, plus z, it must give we 1900, you know. If it don't give we 1900, we made a mistake. We get 1900, so we know we're correct. Z is 5 bills. Alright? So we know that we're correct now because we check it. So look what I'm saying, guys. Always check your answer as you finish the question. You don't need to complete the paper and then check over. Please don't wait until the end of the exam to check over. And that finished module 1. Alright, module 2. Module 2, it says a psychologist is studying the sleep patterns of 3,960 students of Phillips College. She decides to start by asking a random sample of students how many hours they sleep, get nights during the weekend. Identify the type of sample in each of the following survey methods. It says the psychologist assigns the name of each student to a number 1 to 3,960. She has a lot of time. She selects the sample by randomly choosing one of the first 132 numbers and every 132 number thereafter. So this is systematic. This is systematic sampling. Alright, so systematic sampling is where you place in order, and what you're going to do is, if you check it out, this is 3960. If we divide it by 132, we get 30. So that means you're choosing 30 numbers randomly, right? But it's not really random because she made it systematic. So from the first 132, she randomly choose 1. From the next 132 numbers, she choose 1. Then from the next 132, she choose 1. And she do that all the way up until she choose all 30. This is systematic sampling. Okay, so she had a lot of time on her hand to do that. Now the psychologist assign a name each, numbering from 1 to 3,960. Use a computer to randomly generate a list of 30. Nice. So now she's using my favorite, simple random technique. This is my favorite because nobody has time to do a systematic. Simple random sampling. Now the next one says, students are listed by their neighborhood in which they live. The psychologist randomly selects 6 neighborhoods and uses the students from those 6 neighborhoods to form the sample. So in this case, it is, notice it's 6 different neighborhoods, but of course it's still random. The psychologist randomly selects 6 neighborhoods. So in that case now, it is stratified. And then the last one says an equal proportion of students is randomly selected from 5 departments at the college. Alright, so in this case now, we're breaking them down by department, so we're doing it now by cluster. And that's that. So that's a different type of sampling. Alright, and we finish with that. So that's just some stuff to remember. It says now the following table shows the heights in centimeter of 51 children. Find the mean height. So we have to remember, how do we find mean for group data? Mean for group data is bar x, and it's the sum of fx over n. So in this case now we need the midpoint of each group. That will be our x. So I'm just going to put an extra column here, x column, and this x is the midpoint. Midpoint of 140 to 150 is 145, 155, 165, 175. Alright, and it shows a height of 51 children. So you're telling me no student is over 6 feet? Because remember, 6 feet is 182.8 centimeters. So no student is above that? That's crazy. So now it want the mean height. So the mean height, as we know, bar x is equal to the sum of fx over n. So we multiply f times x. So it's 145 times 6 plus 155 times 16 plus 165 times 21 plus 175 times 8, and we divide it by the total number of children, which is 51. So in that case, bar x equal to, we take out our calculator and we put it in. So fraction button, 145 times 6 plus 155 times 16 plus 165 times 21 plus 175 times 8. And we put that in our calculator, divided by the 51, of course, and we get 161.1 centimeters. 161.1 centimeters. That's the mean height. So the average height is roughly just about 5 feet and 4 inches, somewhere in that region. So in this case now, the question says to evaluate the standard deviation. This is where we're going to need to remember the formula for standard deviation. So standard deviation, I'll write it right here. The standard deviation is equal to the square root of, you have to remember it now, it's the sum of fx squared minus the sum of fx all square over n, all divided by n minus 1. That's the formula for standard deviation. So now we're going to need a column for x squared. I'm just going to put it at the bottom here. Let me attach it. Let me attach it in black. X squared. So we need 145 squared. That's 21,025. Then we need 155 squared. That's 24,025. 165 squared. That's 27,225. So far everything ends with 25 because we know of the 5 square. Then 175 square, that's 30,625. Hey! Whew, we're good now. So let's go ahead and work out the standard deviation. Now I'm going to zoom out, and it might not be as clear when I zoom out, but it's just so I can see the table and do the question at the same time. So in this case, the standard deviation is now equal to, remember, it's a sum of fx squared. So I don't have enough space to work out fx squared. So look what I'm going to do. I'm going to write the sum of fx at the top. Yeah. Because I don't have enough space. Based on how they gave us this question, we don't have enough space to do all of that. So I'm going to, don't worry, I'm going to write the sum of fx at the top of the screen because they didn't give us enough space. Alright, so in that case now, look what I'm doing. I'm just making a column that says fx squared. Alright, imagine that it's connected to this table, fx squared. So we're just multiplying it at the top up here. So 6 times 21,000, 6 times 21,025. That's 126,150. Then now we need to work out 16 times 24,000. 16 times 24,025. That is 384,400. And then we need to work out 21 times 27,225. 21,000 times 27,225. And we get 571,000 and 725. And finally, we work out now 8 times 30,625. So 8 times 30,625. And we get 245,000. 245,000. And that's it. So now we need to add up everything, and then that gives us the sum of our fx. So the sum of our fx square, add up all of those numbers. Alright, so this plus 571,725 plus 384,400 plus 126,150. Bam! That's 1,300,000. Let me just write it down. That's a big number for me to remember. It's 1,327,725. So that's what we have. So now we're good. So now we can go ahead and work out the standard deviation. So I'll zoom out. So it's now the square root of, as we say, it's now 1,327,725 minus, now the sum of fx square. Now the sum of fx, what was the sum of fx? I didn't write it down. So sum of fx would be what we had in the numerator in part 1. So 145 times 6 plus 155 times 16 plus 165 times 21, 175 times 8. So we put that in the calculator and it was 8,215. Hey! So this is 8,215 square. Then we divide it by n51 all over 50. Now the good thing is, if you have a calculator like this, you don't need to worry. You can put everything in the calculator one time. But to actually show them that you work it out, we're going to put in our 8215 square. Then we divide that by 51. Then now we're going to say 1,327,725 minus our answer. That's what we get, 4,465. So we're going to show them that part. We show them that the numerator part under the square root worked out to be 4,465.8 divided by 50. Then now we're going to divide it by 50. And then we square root it. So now our standard deviation is just 9.45. So the standard deviation is 9.45. So that means each person's height on average deviates from the mean by about 10 centimeters or 9.45 centimeters, which is not bad. That's a standard deviation. That's not bad at all. Alright, this question, it says, a team of 3 girls and 3 boys is to be chosen from 6 girls and 5 boys. It says find the number of ways in which a team can be chosen. So the total number of ways the team can be chosen, C represents chosen, is how many persons are we choosing from in total? In total, we're choosing from 6 plus 5 is 11. We're choosing from 11 persons. From those 11, how much do we want? We want Alright, so we want a team of 3 boys and 3 girls. So we want 3 boys and 3 girls. Okay, no problem. So actually what we're choosing then is 3 boys from 5 and 3 girls from 6. So that's what we have to be choosing from. Alright, so it's 11 persons in total, but we're choosing 3 boys. So we're choosing 3 boys from 6. Multiplied by, now we're choosing 3 girls from 5. Or did I say it the wrong way around? We're choosing 3 girls from 6 and 3 boys from 5. And then we multiply them. Very easy stuff. So 6, choose 3, that's 20, times 5, choose 3, 5, choose 3, which is 10. And so there's 200 ways to do that. So there's 200 ways that we can select our team. Very easy. Nice. Now part 2. Part 2 says Sarah and Hannah are in group of 6 girls. Find a number of ways in which the team may be chosen if neither Sarah nor Hannah is on the team. So we already eliminate Sarah and Hannah not on the team. So if Sarah and Hannah is not on the team, that means you have 4 other girls can be chosen. But how many out of those 4 girls we need? We need 3. So if Sarah and Anna don't on the team, that's good for us. It makes it easier for us to work out. So that means we're choosing 3 girls from 4 times, or same, choosing 3 boys from the 5. So in that case, 4 choose 3 would be, put that in the calculator, 4 choosing 3, which is 4, times 5 choose 3, and I think 5 choose 3 was 10. 5 choose 3, 10. So work that out, we get 40 ways. So basically, if Sarah and Hannah, them don't make the team, or none of them is on the team, there's 40 ways of selecting our team that compromises of 3 boys and 3 girls. And that is it. Easy stuff. Nice. Alright, part D. Part D says the probability density function shown in the following table defines a discrete random variable where the mean is 2.7. Show that A equals 3. Remember, E of x, the mean, is equal to the sum of x times the probability of x equal to x. So in this case, we're saying that 2.7 is equal to 1 times 0.1 plus 2 times 0.3 plus 8 times 0.4 plus 4 times 0.2. That's what we're saying. So in that case, we're getting 2.7 is equal to 0.1 plus 0.6 plus 0.4 times A plus 0.8. So of course, to do our little addition, 0.1 plus 0.6 plus 0.8, that works out to be 1.5. So we can bring the 1.5 to the other side to say 2.7 minus 1.5 equals 0.4a. 2.7 minus 1.5 is 1.2. So 1.2 equals 0.4a. So if we divide both sides by 0.4, we'll get a is 1.2 over 0.4. And we'll put that part in the calculator. That part is relatively simple. 1.2 divided by 0.4. Absolutely get our 3. So there we go. Show it. Nice. Now these questions we like because you don't have to check it over. Once you show what they want, you're good. So that's that. Now, the next part of the question says find the variance of x. Now this is where you're going to need to remember the variance formula. Remember that var x is equal to e of x squared minus e of x all square. That's the variance formula. So first thing we need to work out is what is e of x squared. So let's do it in a different color first. So firstly, we can tell them e of x squared would be equal to x squared times the probability x equal x. So e of x squared is 1 squared times 0.1 plus 2 squared, which is 4, times 0.3 plus 3 squared times 0.4 plus 4 squared times 0.2. That is our e of x squared. So put that in our calculator. 1 times 0.1 plus 4 times 0.3 plus 9 times 0.4 plus 16 times 0.2. In that case, put all of that in the calculator and we're getting 8.1. So e of x squared is 8.1. So now we can go back to var x and say var x now is equal to e of x squared 8.1 minus e of x all squared. But e of x, they told us, was 2.7. That's minus 2.7 squared. Punch that in our calculator. 8.1 minus 2.7 squared, and we get 0.81. So that's var x. The variance is 0.81. That was so easy. Nice. And that takes care of question number 3. So easy. That was so easy and so fun. Nice. Alright. Question 4. Wow. It says the following table shows some of the data from a survey carried out among households in a certain district to determine their preferred laundry detergent brands for babies. The data is to be presented in a pie chart. Then they said to work out B and to work out A. No problem. We need to work out B and we need to work out A. So if we have a pie chart, we don't know how the pie chart is distributed. We don't know what else could be in the pie chart, but we know that Burex take up 91 degrees. 91 degrees for Burex. And we know that Ink Show take up 72 degrees. And we don't know how much Dreft take up. And we don't know if there's anything else in the pie chart. Alright? So they didn't put any other. So we don't know. So we just need to work out what we do know. What we do know then is that, remember, we know that for the Burex, we know that 91 degrees out of 360 times the total number of household. Let's call the total number of household T. We know that 91 out of 360 times the total T must give us 64. So in that case, we're saying, okay, if we divide both sides by 91 over 360, this would cancel. And so T is just 64 divided by 91 over 360. So in that case, the total is going to be, so here we go, 64, divided by 91 over 360. And that gives us 253. So in that case, the total number of households, so the total number of households is 253. So that is T. So since T is 253, now we're able to find A. Now we can say that the 72 degrees out of 360 times the total of 253, that must give us A. Because remember, that is A for Ink Show. So now we can put that in our calculator. 72 out of 360 multiplied by 253, and that is 51. So A equal 51. So there's 51 households for ink shoe. That is A. That's your 2 marks. Easy stuff. There's literally nothing there. Alright, easy stuff. Now we need to work out the value of B. Now that we need to work out the value of B, what do we know? We know that B have 100 and the angle B, it would be B out of 360 times the total household 253. That's going to be equal to 105 because it's 105 households for drift. So in that case, we can of course write it as 1 and say this is 253b over 360 equal 105. So what we're saying then is b is 105 divided by 253 over 360. So now we just put that in our calculator and that gives us b. So 105 divided by another fraction button, 253 divided by 360, put that in, and we'll get 149. B equal 149. But remember, B is degrees, so it's 149 degrees. Alright, so that is B. So if you go back to your pie chart, if B is 149 degrees, that's drift. So drift 149 would be something like this. So this is drift. So maybe you have what you call an others chart. So drift is 149 degrees. And you have others that would accumulate to something else. Right? Maybe 30 something looking at the diagram. So that is what we have. Alright? Easy stuff, like this is literally pie charts. This is something that we should be able to do from grade 7 or grade 8. So no problem, it's just pie chart. Alright, part B. Part B says, the following stem and leaf diagram summarizes the length in minutes spent by 13 employees completing a job. So a person's taking 5 minutes, 6, 7, 8, 9, 10, 11, 17 minutes. And the longest somebody takes is 41 minutes. So that person is extremely slow in comparison to somebody taking 5 minutes. It's 13 employees. So how do we find the median? Determine the median. The median, first thing you have to do is find the position of the median. The position of the median is a half the n plus 1 position. So it's a half 13 plus 1, which is 14 over 2, which is 7. So looking for the 7th time. 1, 2, 3, 4, 5, 6, 7. This is the 7th time. So the median time is equal to 11 minutes. That's the median time. Nice. Now the next part of the question says to find the lower quartile. So find the lower quartile time. So to find the lower quartile time, we're going to be like, okay, we need to find the position of the lower quartile. So the position of, we call the lower quartile Q1. So it's a quarter of 13 plus 1, which is 13 plus 1 is 14. 14 over 4 is 3.5. That's 14 over 4. So 3.5 would be in between the third and the fourth term. So third is here and the fourth is here. So the lower quartile is the average of that, which is 7.5. So therefore Q1 is equal to 7.5 minutes. That's our answer. Alright. The next thing it says, use the axis below to construct a box and whisker. So we need a box plot. Since we need a box plot, we know we're going to need to find our upper quartile. So let's do it around here. Q3. Our Q3 is going to be the upper quartile, which is 3/4 of 13 plus 1, which is 14 times 3 is 42 over 4, and 42 over 4 is 10.5. So 10.5 would be, let's go, so 5 terms, 9, 10, 10.5 is in between 24 and 26. So Q3 is just equal to 25 minutes. That's our upper quartile, 25 minutes. Nice. So now we can do our box plot, because the box plot is our 5 summary data with the median, the lower quartile, the upper quartile, the lowest, and the maximum. So, alright, I like to use a proper box. Right, don't worry, we're gonna move it. So using the proper box, the lower quartile was 7.5 minutes. So we're gonna move over our box a little bit. Want to move it 7.5. Somewhere here look like 7.5. This look like 7.5. And then our upper quartile, going back around here, was 25 minutes. So don't want it extend too far. We're going to 25 minutes. This is our upper quartile. Yeah man, everything coming smooth. Upper quartile 25 minutes right there. Then our lower quartile was, where's the lower quartile? 7.5. Then our lowest was 5 minutes and our highest was 41 minutes. So now let's extend now to 41 minutes. Somewhere out here look good enough for 41 minutes. And 5 minutes the shortest time. Somewhere right here. 5 minutes. We're just trying to make it look neat. This is our lowest. This is our highest. 41. 25. 7.5. Then of course the median we said was, what was the median again? The median was 11 minutes. So 11 minutes would be somewhere here. This is our median, 11 minutes. Wow! So that's it, our median was 11 minutes. Alright, so of course, this is our min. This is our Q1, Q2, Q3, and our maximum. Maximum time was 41 minutes. Alright, part C. Part C says, given x follows a binomial distribution of n and 0.4, where the mean is 3.2, show that n equal 8. First thing is, for binomial distribution, the mean e of x is equal to n times p. And they told us the mean was 3.2. So 3.2 is equal to n times p, and p is 0.4. So divide both sides by 0.4 and that will give us n. So dividing by 0.4, n equal 3.2 divided by 0.4. 3.2 divided by 0.4, which is 8. So there we go, we show it. Now we love these type of questions because you don't have to check over. You literally don't have to check over because it's a show question. Now the next part of the question says, find the probability x is greater than or equal to 6. Remember, n stops at 8. So being greater than or equal to 6 is the probability x equals 6 plus the probability x equals 7 plus the probability x equals 8. And you stop there. So the probability x equal to 6, remember now, it's n choose, so it's 8 choose 6 times p. P is 0.4, so it's 0.4 to the 6 times 0.6. Now if p is 0.4, if this is p, then q is 1 minus 0.4, which is 0.6. So that's where we get this 0.6 from, and it's 0.6 squared. Plus, it is now 8 choose, x is now 7, so 7, then it's p to the x, 0.4 to the 7, times 0.6 to the 1. Alright, look like 0.61, but this is 0.6. Let me write it a little better. 0.6 to the 1, plus it is then 8 choose x is 8 times 0.4 raised to the 8th power times 0.6 to the 0. They punch that in your calculator. I will work them out piece by piece. So piece by piece we have 8, me bracket it, 8, shift, then divide, give us C, 8 choose 6, multiplied by 0.4, that's raised to the 6th power, and then we multiply it by 0.6, and then we square it, plus we then have 8 choose 7, 8 choose 7 in bracket, multiplied by 0.4, that's raised to the 7th power, and then we multiply it by 0.6 raised to the 1st power, and then we have plus 8 choose 8 in bracket, that's multiplied by 0.4 raised to the 8th power times 0.6 to the 0 power, sorry. So I decided to put everything in the calculator one time, and that's what we get. Putting everything in the calculator one time, I want to make sure everything was smooth to the 6th, to the 2nd, plus 8 choose 7. Yep, everything is smooth, and we got 0.0498, which is approximately 0.05, which is approximately 5%. So there's a 5% chance x is going to be greater than or equal to 6. Makes sense. If the mean is 3.2, then chances are x is going to be somewhere between 2 to 4. Because usually going to be like within one standard deviation of the mean, right? And if the mean is 3.2, the standard deviation would be 3.2 times 0.6, 1 point something. Alright, so usually within one standard deviation of the mean. So this looks very good. This looks like an accurate number. We're good. The next part, normal distribution, the best part of statistics. It says the mass of barrels arriving in a specific country follows a normal distribution, so let's call it X, follows a normal distribution with mean 140 and a standard deviation of 5. So the variance is 25. It says show that the z-value of a mass of 132 is negative 1.6. Remember, z is equal to the x value minus the mean divided by the standard deviation. So it's 132 minus 140 over the standard deviation of 5. 132 minus 140, that's negative 8 over 5. So the z-value is indeed negative 1.6. So we showed it. We like these questions because these questions nice. It's just a show. Now the next part says, find the probability that a barrel selected at random weighs more than 132 kilograms. In other words, find the probability X is greater than 132 kilograms. In that case, we have to standardize it first to get the probability that Z is greater than. Remember, the standardized value for 132 is negative 1.6. But the probability Z is greater than negative 1.6. You have to remember your normal table. This is the normal table. Standardized with a mean being 0. So negative 1.6 somewhere here. So being greater than negative 1.6 is all of this. So what we're saying is that this is equal to the probability also that Z is less than 1.6. So all we need to do is go to our normal table. So I don't have the normal table, so I'm going to try and open the normal table online. Alright, so I got out the normal distribution table, and we're looking for a z value of 1.6. So the z value of 1.6 corresponds right here to, as you can see, it corresponds to 0.9452. So 0.9452, that's 1.6. So we can write that this is equal to 0.9452. In other words, there's a 94.5% chance. So that is, there is a 94.52% chance the barrel is heavier than 132 kilograms. Alright, so pretty much the barrel is definitely going to be heavier than that amount. That takes care of that. Alright, now this question, it says, at a town hall meeting in town A, the residents discussed the issue of flooding after heavy rainfall. The drainage division monitored the situation and recorded the level of water at 7 different distinct districts in a given town. The following table summarizes the finding. Now it says, on the grid provided on page 19, draw a scatter plot. So just need to plot these points. The very good thing for us is they give us what to plot on each axis. So all we need to do is go ahead and plot the points. So we're plotting 3 to a half. So when the time is 3, right, this would be 1, 2, 3. Right here is 3. So plot 3 to a half. Now on the y-axis, looking at it, we're going up 1, 2, 3, 4, 5. So each is 0.2. Let me zoom in so you can see what I'm saying. I'm saying on the y-axis scale, as you can see right here now, 0.2, 0.4. So 0.5 would be in between. 0.5 is therefore somewhere here. So I'm using red points. Alright. Now the next point we're plotting is the time is 6 minutes and the height is 4. So 6 minutes to 4. So 6, here is 6 to 4. 4 is up here. Okay, I skipped over 1. Here is 6. 6 to 4 is right here. Nice. You want to make sure you're plotting these points accurately. Okay, then you have 10 minutes to the level of water being 6. So now it's getting easier to plot 10 to 6 right here. Then we need to plot 18 to 8. That's easy to plot as well. 18 minutes. So this is 15. This is 17 and a half. This is 18. 18 minutes to a height of 8. That's right here. And then we need to plot 20 to 10. 20 minutes to a height of 10. That's right here. Then we need to plot 28 to 10. So notice 8 minutes go by and the level of water don't even increase. Now that's crazy. So 27 and a half, this is 28. And the level of water don't even flinch. It remains constant. So all the way here. And then finally, at 35 minutes, the height of the water reached 12 centimeter. So the height of the water reached 12 centimeter at how many minutes? 35. So at 35, height of the water reached 12. This is it. And of course, it's a scatter plot, so we need our line of best fit. So let me pull out a different color, going for the blue. So the line of best fit, we want to make sure it's relatively accurate. So alright, we have to have same number of points on the left and the right of it. Alright, so we have 1, 2, 3 to the right, 1, 2, 4 on the left. I mean, this is relatively accurate. They won't kill you for this. Alright, 1, 2, 3, I would love to get passing through 1, and so I have 3 on the left and 3 on the right, but they won't penalize it for this. Alright, so that is what we have. Alright, so we have 3 to the right and 4 to the left of the line. Alright, that's what we have. That's our line of best fit. Alright. Now in that case now, it says, briefly comment on the shape of the scatter plot. So to comment on the shape, now, to comment on the shape of the scatter plot, as we can see right here, we can see that there's a positive correlation. It's clear to see there's a positive correlation. Alright, so we can write that down. So we can see there is a positive correlation between the time and level of water. So there's a positive correlation. How do we know positive correlation? Always remember, if the graph look like this, that's positive correlation. If the graph is like this for the most way, correlation is 0. And if the graph come down like this, negative correlation. Alright? So it's positively correlated. Now, we don't know if it's moderately correlated, strong correlation, or any of that. We'd have to work out R. But you don't need to work out R for 1 mark, don't it? For 1 mark, this is good enough. You don't need to work out R. That's why it says briefly or shortly. That's it. And now we're on to module number 3, calculus. So the first part of the question, it says, we have a piecewise function right here. Work out the limit when x is approaching 1 from the right of it, when x is greater than 1. Greater than 1 is the top one. So we can say now the limit as x approach 1 from the right of f of x, that is equal to the limit as x approach 1 of the top function of 1 over 2x minus 1. We can input 1 directly and we get 1 over 2 in bracket 1 minus 1, which is 2 minus 1 is 1 and 1 over 1 is 1. So therefore, just to conclude, the limit as x approach 1 from the right of f of x is equal to 1. Nice, easy 2 marks, no problem, no biggie. Part 2. Determine whether f of x is continuous at x equal 1. Now it is continuous if the limits from both sides are equal. So now the limit as x approaches 1 from the left of f of x, that be equal to the limit as x approaches 1 of 4x minus 3. Put in 1, we get 4 minus 3, which is 1. Now, since both limits is equal to 1, we can write, now, since the limit as x approaches 1 from the left of f of x is equal to the limit as x approaches 1 from the right of f of x, which is equal to 1, therefore, and we also know the function is defined at x equal 1. So they told us it was defined at x equal 1. So in that case, we can say, therefore, f is continuous. F is continuous at x equal 1. So it is continuous, and we get another 2 marks there. Easy. Easy stuff so far. Nice. Alright, no stress so far. No stress at all. 4 giveaway. Alright, now part 2, it says, given that f of x is x cubed ln x, find the first derivative. So to find the first derivative, f prime of x, we're going to use product rule. Product rule is like this. If f of x is the first times the second, then f prime of x becomes equal to keep the first times the derivative of the second plus keep the second times the derivative of the first. You don't need to write no whole heap of u and v. right? Stop putting so much u and v on the paper. So this is what we're going to do. We keep the first, x cubed. Now multiply it by the derivative of the second. When you differentiate ln 2x, it becomes 2 over 2x. Plus, you keep the second is ln 2x, then you multiply it by the derivative of the first, 3x squared. So f prime of x is equal to now 2 over 2x is just 1 over x. So that is x cubed over x plus 3x squared ln 2x. But guess what? We know that x cubed over x is just x squared. So f prime of x is just x squared plus 3x squared ln 2x. That's our answer. Nice. Cool. Now the second part of the question, it says determine the derivative of the function g of x equal e to the 2x plus cos 3x. So in this case, we can say g prime of x, which is our derivative. When you differentiate a exponential, you just find the derivative of what's in the power. So the derivative of 2x is 2, so it's 2e to the 2x. Then when you differentiate cos, you get minus sine. So it's minus sine 3x. But then you multiply it by the derivative of 3x, which is 3. So therefore, g prime of x works out to be 2e to the 2x minus 3 sine 3x. And you're done. Piece of pie. Piece of pie. Easy 3 marks. Alright, part C. Part C says the population count over time t in days of a certain type of insect can be modeled by this function. Find the second derivative. So we need to just differentiate twice. So p prime of t would be, differentiate a constant, you get 0. Differentiate minus 5t, you get minus 5. Differentiate 0.77t squared, you carry down the power. So plus 2 times 0.77. And then you subtract 1 from the power is t. Then minus, carry down the power 3 in bracket 0.01, then subtract 1 from the power, it's t squared. So p prime of t is just negative 5. 2 times 0.77, you can put that in a calculator. 0.77 times 2, that's 1.54. So plus 1.54t. Then 3 times 0.01, that's minus 0.03 t squared. Now for the second derivative, so p prime prime of t will be 1.54. Then carry down the power 2 times 0.03. So 0.03 times 2 is 0.06. So this is now minus 0.06 t. That's the answer. Nice. Now it says, given that the function p of t has a stationary point when t equals 48, show that the stationary point is maximum. So we know a maximum stationary point. We know that the second derivative, d2y by dx squared, should be less than 0. That's how we show it's a maximum stationary point. So we can say at t equals 48, p double prime of 48 is equal to 1.54 minus 0.06 times 48, and this will give us a negative value. So we have 1.54 minus 0.06 in bracket 48. Put that in the calculator and we get negative 1.34. Negative 1.34 is what? Less than 0. So we can conclude, therefore, at t equal 48 is a maximum stationary point. So good. Finish with that. Nice. No issues at all. Since we're finished with that question now, we can move along. It says find the population count when t is 48 days. So now we just need to find the population when t equal 48. So all we're doing is plugging t equal 48 into the original function. So I'm going to zoom out. It's going to look a little smaller for a sec, but it's because we have to see the function. So p of 48 is, put the 48 in the equation at the top. So 207 minus 5 times 48 plus 0.77 times 48 square minus 0.01 in bracket 48 cube. So that's P of 48. P of 48 works out to be, you work out all of that in your calculator. So this is now 207 minus 5 in bracket 48, close the bracket, plus 0.77 in bracket 48 square. Then we have minus 0.01 in bracket 48 cube. Punch that in the calculator and we get 635. So the population is 635. That's the population count. 635 insects. Alright, make sure we didn't put in any error in the calculator. Always check it. 0.77, 48 square. Good, we didn't put any error in the calculator, so we're good. Alright, so that is that. 635 insects. Nice. Okay, now the next part, part D, it says a spherical balloon is inflated. The radius r of the balloon is increasing at a rate of 0.2 centimeter per second. So they give us that the radius of the balloon is increasing at a rate. So dr dt is 0.2. Now it says obtain an expression for dv by dt. First thing is, we know that dv by dt is going to be equal to dv by dr multiplied by dr dt. Because the dr dt's then cancel, don't? Nice. So all we need to do is find the expression for dv dr. But if volume is 4 over 3 pi r squared, pi r cubed, then dv dr is just carry down the power. 3 times 4 over 3 is just 4. Subtract 1 from the power, so 4 pi r squared. So in this case, an expression for dv dt is 4 pi r squared multiplied by dr dt, and dr dt will already know that is 0.2. So in that case, that's the expression for dv dt. If you want to simplify it, that's up to you, that's fine. So you can say 4 times 0.2, which is 4 over 5, or 0.8. So you can say it is 0.8 pi r squared. That's the answer. Alright? So you're telling them that dv by dt is just 0.8 pi r squared. Now, why didn't I keep a fraction? Because they gave me a rate in terms of decimal, so I want to keep the rate in terms of decimal. Now, the next part says find the rate of increase of the volume of the balloon dv by dr at the instant when r equals 5, giving your answer in terms of pi. Now notice they want dv dr. We know that dv dr is equal to 4 pi r squared. So now when r equals 5, then dv by dr would be equal to 4 pi in bracket 5 square, and 5 square is 25. 25 times 4 is 100, so this is 100 pi. But dv by dr, this is volume. Volume is centimeter, so volume, remember, v is cm cube, and cm cube over radius is centimeter, so this is cm squared. Now notice that the question said rate, so they made an error in the question. They made an error in the question. Rate of increase of the volume. Rate of increase, so notice you give them the answer. Now you can be bold enough and tell them rate of increase is dv dt. So you can tell them the wording is not correct. You can be bold and tell them that, and say, CXC, please fix your wording. Please fix wording. Because rate of increase would be dv by dt. And dv by dt, when r equal 5, would be 0.8 pi times 5 squared. That would give us rate of increase. Rate is with respect to what? Time. Rate is with respect to time. Clearly, the answer we had right here. Make sure you give them this, because they say find dvdr. That's dvdr, but that's not rate of increase. Rate of increase is with respect to time. So rate of increase, 5 squared is 25. So 0.8 times 25 is 20. So this is 20 pi centimeter cube per second. This would be rate of increase. We're saying then that for every second, the volume increased by 20 pi. That is rate of increase. So you can be bold and tell them, so this is rate of increase. Alright, so this right here is the actual rate of increase. This is the rate of increase. Be bold and tell them, so CXC, stop make error. Make even the examiner have to read the paper and tell them, say wording is not correct. Please fix. That is not rate of increase. What they wanted was not rate of increase. dv by dr is not rate of increase. Okay, now we're on to question number 6. Question number 6 says, determine the following integral. We need to integrate 4x plus 7 to the 6th power. So this is an indefinite integral. I like to call my integrals I, right? So let I be equal to the integral of 4x plus 7 to the 6th power. So in that case, we're saying I is equal to add 1 to the power. Then you divide by the power of 7. But then you also divide by the derivative of what's in the bracket. The derivative of 4x plus 7 is 4. But remember, when you integrate, you put your constant of integration k. So in that case, I equal, we can write our answer is 4x plus 7 raised to the 7th power over 4 times 7, which we know is 28, plus k. That's our answer. So I like to define my integrals. I don't like to just start integrating. Now here, now we need to work this out. So I'm going to call this integral j. Let j be equal to the integral of 5x cubed minus 3x squared plus 1 dx. So what we're saying then is j is then equal to add 1 to the power 5x to the 4, divide by the power 4, minus add 1 to the power, that's 3x cubed over 3. But instead of writing 3x cubed over 3, that looks ridiculous. Just write minus x cubed. And then plus 1, when we integrate 1, we get x. Then remember to put plus your constant of integration, k. So that's your answer. Please don't write 3x cubed over 3 and then do the division. Save yourself the time, man, right? It's just 2 marks. Don't stress yourself. That's your answer. Now the next part of the question, part B. It says evaluate the definite integral from 0 to pi over 2 of cos x plus 2 sin x. So I'm just going to call this integral I again, or I1. So I1 is the integral from 0 to pi over 2 of cos x plus 2 sin x dx. So in that case, I1 is equal to, when we integrate cos, we get sin x. When we integrate sin, we get minus cos. So this is minus 2 cos x. And when we integrate, we're going from 0 to pi over 2. So I1 is now equal to when we put in pi over 2, this is sine pi over 2 minus 2 cos pi over 2, close that bracket, minus, when we put in the 0, we have sine 0 minus 2 cos 0, close that bracket. So in this case, I1 is equal to sine pi over 2 is 90, and the cos of 90, the sine of 90 is 1, so this is 1, minus the cos of 90 is 0, 2 times 0 is 0. Subtract over here, sine of 0 is 0, minus the cos of 0 is 1, so this is now minus 2. So this works out to be I1 is just 1 plus 2, which is 3. So that's your area. That's the definite integral, 3 units square. Now, look what I love about this calculator. Guys, get a Casio FX570, 991 or 115. These types of questions, you can actually integrate it. Exactly, look, integrate from 0 to pi by 2 of, the expression was cosine x plus 2 sine x, close the bracket, and then we're integrating from 0 to pi over 2. You get your 3. See it there? If you have one of these calculators, you can check your answer. There's no way you should do an integration question and not get it correct. Wow! Because if you have one of these calculators, you check your answer. Alright? Nice. Alright, part C. Part C says the rate of increase of a population at any time is proportional to the population P. Rate of increase is what? Increase of the population. Now guys, look at what I'm saying. Rate is always what again? Time. You see why question 5 did word it bad? Rate of increase is always with respect to time. Look at question 5. Rubbish. How can you say rate of increase and it's over it's dr? That don't make no sense. You can tell them wording is not correct. CXC, please fix wording. You see how question 5 was rubbish? Yes. Well, let's continue back to our question. So rate of increase we know is dp by dt, population with respect to time. They say it's proportional to the population p. So in other words, we're saying then that dp by dt is equal to k times t. So in that case now we can cross multiply to say dp is equal to kt dt. Now we're going to integrate both sides. So remember, this is really 1 dp. So we can integrate both sides now. Integrating both sides, when you integrate 1, you get p. And alright, so scratch, error here. What happened to the p? Oh, this p turn a t. I hope everybody would have been looking how that p turn a t. So, big mistake there. This should have been the p. When we cross multiply, it's dt. It's cross multiply now. So, that t should have been a p. And if that t is a p, then it can't be here. That t should have been a p. Then we can't integrate it like this. We'd have to divide both sides by p. So we'll put the p here and get this p out of it. It's a big error there. My apologies. This is now dt. So in that case, when you integrate 1 over p dp, remember we get ln p. So ln p equal, we integrate this, we get kt, but then we have plus our constant c. Now in this case, we have to, since we need to get rid of ln, we have to then, e raised to both sides now. So e to the ln cancel each other. So now we get p equal e to the kt plus c. That's it. Nice. Alright. So that takes care of part 1, no problem. Part 2 now, it says find c. So to find c, first thing it tells us is when t equals 0, p is 4,000. So they're telling us that, remember the equation for p is above it. 4,000 is e to the k times 0 plus c. This is really just 4,000 equal e to the c. So that gives us our constant. So really and truly then, to find c, we just take ln both sides. So c is just ln 4,000. That's c. Easy stuff. Nice. So c equals 4,000. Now, since we know that e to the c is 4,000, we're good. Now, the next part says, given that k equal ln2, determine the population size when t equals 3. So first thing we know then is p is equal to, it's e to the kt times e to the c. I'm breaking it up using laws of logarithm. Remember, e to the kt plus c, you can break it up as e to the kt times e to the c. Why did I do that? Because I know e to the c is 4,000. So this part of it is 4,000. So I'm saying then that p is equal to 4,000 times e to the kt. Now, why did I do that? I did that because now we can find the population when t is 3. When t equals 3, so when we plug in t as 3, we're getting the population is going to be 4,000 e to the k this is ln2, and that's multiplied by 3. So we can write 3 ln2. So we just put that in our calculator. 4,000 e raised to the 4,000 e raised to the 3 ln2. And that's 32,000. So p equals 32,000. That's the population in 3. Is it years? It couldn't be days. It must be years. Let me see. Yes. In 3 years, the population just skyrocket. So remember, I know when time is 0, 4,000. 8 years time, 3 years time, the population skyrocket to 32,000. That's 8 times 4,000. So the population skyrocket. Now part D. Part D says the following diagram includes a parabola, f of x being 30 minus x squared, which models the exterior boundary of a school compound, and the line g of x 2x, which models the fence that protects the shaded region as a reserve for agricultural activities. These are the superimposed on the Cartesian plane where q is the x-coordinate of the point where the line g of x meets the parabola. Find the value of q. So it's really the x value at q they want us to find. So the x value at q is where the line meets the curve. So we can say at q, we see that f of x is equal to g of x. In that case, let's solve them simultaneously. So 30x minus x squared is equal to 2x. So I bring over everything to one side. So in that case, I'll bring to the right. So x squared plus 2x. Well, when I bring over to the right, I have 2x minus 30x. That is 0. So just to zoom out a little bit. In this case now, I'm simplifying further. This is saying x squared minus 28x is equal to 0. When you factorize, you get x minus 28 equals 0. So that means x equals 0 or x equals 28. Oh. Alright. So just a while ago, what would have happened is we realized that I found the roots. So the roots I found were 0 and 28. Alright? So remember, they want the point of intersection. We notice that the point of intersection at Q, that's the maximum point on the curve. At Q is the max point of f of x. Alright, so the maximum point of f of x is just, first thing we need to do is f prime of x is equal to 30 minus 2x. We differentiate f of x. Then set it equal to 0 because at a maximum point, the first derivative is 0. So 2x equal, alright, I want to make sure I differentiate it correctly, 30 minus 2x, yes. Bring 2x there, 2x equal 30. Then divide through by 2x equal 15. Now we're good to go. The x value at Q is 15. Thank you. Now we're nice. Now it says using integration. So that's the value of Q. So in other words, Q equal 15. Now that we get the value of Q, it says now using integration determine the area reserved for agriculture. The area given for agriculture is the shaded portion in here. This is what we want. So to find that shaded portion, we can see that the area shaded, I'm going to zoom out so we can see it. The area shaded is just the area under the curve minus the area under the triangle. So it's the area under the curve minus the area under the line. Now the area under the curve is the integral from 0 to this x value. So it's the integral from 0 to 15 of the curve. And the curve, remember, is f of x is 30x minus x squared dx minus the integral of the area under the line. And the area under the line is integrating from 0 to 15 off. And the line they told us was 2x dx. So in that case, now we integrate it. And we'll get this is now add 1 to the power, divide by the power, minus x cubed, add 1 to the power over 3. Going from 0 to 15. Minus, when you integrate 2x, you get x squared. And you're going from 0 to 15. Plug in 15 because you don't need to plug in 0. Because plugging in 0, 0 times anything is 0. So plugging in 15, this is now, remember, 2 in itself 1, 2 into 30, 15. So that's 15 times 15 squared minus 15 cubed over 3. All of this minus, when you plug in 15 here, is 15 squared. I'll put that in our calculator. That will give us the area shaded. So 15 in bracket, 15 square minus fraction button, 15 cube over 3 minus 15 square. And we're done. 2025. So this is 2025. Is it centimeters square? I'll just write unit square. 2025 unit square. That's our area. 2025 unit square. And we're done. Imagine, we're done. We're nice. Literally, that's it. That was boring. So that's it. That takes care of the CAPE Integrated Mathematics 2016. I hope this paper was fun for you as it was for me. Alright, so make sure as you're using this video to practice. I hope it really helped. That you subscribe, help the channel to grow. And remember, the only way you get better at math is if you practice. Do not just practice past papers, but just practice, practice, and practice. Do multiple questions. Alright?